Greetings. This is Rishabh Nahar. Welcome to our channel CodeChef. Today we are going to solve a problem called as cutting recipes. The problem code for this problem is RECIP. This is an easy problem with only one prerequisite, that is Euclid's GCD algorithm. So let's move to the problem statement. The chef has a recipe. He wants to make a reduced version of this recipe which has the same ratios of ingredients. The chef does not like fractions, and so the reduced version should also have whole number of ingredients. We want to help the chef to minimize the array in such a way that every pair of ingredients have the same ratio as it was before the reduction, and every element should still remain a whole number. So let us try to understand the problem by the help of an example. Consider that we were given an array of ingredients which was 4, 8. So now the chef has to make a reduced array such that the ratio of these two elements should remain the same. Initially the ratio is 8/4. So what chef can do is he can reduce the element in such a way that now the second element is 2 and the first element is 1. The ratio will become 2/1, and since you know that 8/4 is same as 2/1, so the ratio is still maintained, and we have reduced the array in such a way that the new array also consists of only whole numbers. So this is a valid answer. Let's take a larger example. So consider that we were given an array of 4 elements, which is 12, 6, 9 and 15. Consider that this array is being reduced to another array, which is 4, 2, 3, 5. Let us check if both the conditions are being satisfied or not. Consider any pair of element. For example, let us consider first and last. So initially the ratio was 12/15. After reduction, the ratio becomes 4/5. We know that the 12/15 is same as 4/5. We can take any pair of element and this property is still maintained. And the new array also always consists of only whole numbers. So both the properties are satisfied. So let us think about the solution. But before thinking about solution, I would encourage you to pause the video and spend some moment to try and solve the problem by yourself. So let us look at the solution. Before solving the entire problem, let us try to solve the problem for the case where there are only 2 ingredients. So if there are 2 ingredients, let them be A and B. One thing that we have to consider is that the ratio of 2 ingredients will remain unchanged if and only if they are divided by the same number. And since the 2 numbers must remain whole number after division, so we have to divide both of those numbers only by their factors. That is, we are given 2 numbers A and B, and now we have to find some value with which we can divide both A and B. Let that value be C. Now this value should be a factor of A and should also be a factor of B, because if it's not a factor of A or B, then upon division, the value that is formed won't be a whole number. And since the chef wants to minimize the final array, so it's better for us to maximize the value of C. In other words, for the case of 2 values, we have to find the maximum factor of A and B, maximum common factor of A and B, which is also called as GCD of A and B. So let GCD of A and B be equal to G. So how can we make the reduced array? If the initial array was A and B, then the reduced array could be A by G, B by G. This reduced array will be a valid answer because upon division, since G is a factor of A, so A by G and B by G, both of these are whole numbers. And since both the values have been divided by the same value, the ratio is also unchanged. So this is how we are going to approach the problem for the case of two elements. We are going to find the GCD and then divide the both elements by the GCD. Now let us try to extend the problem for the case of n integers. Consider that we have an array of n integers which are a1, a2, a3 and so on till an. Since we have to maintain the ratio of each pair of value, so it's necessary for us to reduce the values in such a way that there is one common factor c which divides each of the value a1, a2, a3 and an. So what we are going to do is we have to find some value c such that it's factor of a1, a2 and an, and then our reduced array would be a1 by c, a2 by c and so on till an by c. And we have to find the maximum value of c, because if we find the maximum value of c, we are indirectly minimizing the array. So this is again the GCD of entire array. So what we have to do is we have to find the GCD of the entire array, and that value we are going to consider as our c. After finding that value, we are going to divide each individual element by that c, and that would be the representation of initial a1 in the reduced array. That is, a1 will become a1 by c, a2 will become a2 by c and so on. Now we need to know a property of GCD, which is the GCD of a comma b comma c is same as GCD of a comma b and c. Using this property, what we can do is we can find the GCD of entire array. How can we do that? In order to find the GCD of entire array, what we can do is maintain some variable g. Initially, this variable g will be GCD of a1 and a2. After which, what we are going to do is we can take all the other elements, that is a3 to an, and find the GCD with g, and then update the g with the resultant GCD. That is, g will be equal to GCD of a3 and g. After that, g will be, and at last g will be equal to GCD of an and g. In this way we are going to find a GCD of the entire array, and then the final reduced array would be a1 by GCD, a2 by GCD and so on till an by GCD. In order to find GCD, we have two options. Consider that we are using a language like C++. So in C++, we can use underscore GCD, and it would give us the GCD of two values. Or either we can implement GCD by using Euclid's algorithm. We can use Euclid's algorithm to find GCD of two numbers a and b in the time of O of log minimum of a comma b. In simple words, this is Euclid's GCD algorithm. That is, GCD of a comma b is equal to GCD of b comma a mod b. We can use a recursive function to find the GCD. But then what will be the our base case? Our base case can be that when b is equal to 0, we would have to return a. So let us start coding the problem. But before starting to code, let us look how input and output works for this problem. So initially we are given a number of test cases, and after that we are given n lines, such that each line has first number, which is the number of elements in the ingredients array. After that there are n number of elements, such that each element represents the element of the ingredient array. For example, here we have 4. So we have 4 elements which are the element of the ingredient array. And what should our output be? Our output should be the reduced array. That is, here 4 comma 4 can be reduced to 1 comma 1. So our result is 1 comma 1. Here 2, 3, 4 cannot be further reduced. So our result is still 2, 3, 4. And 3, 15, 9, 6, as you saw in the example earlier, can be reduced to 1, 5, 3, 2. So let us start coding. So initially we have taken t, which is the number of test cases, and after that for each test case we are calling the solve function. In this solve function we have to first take the input of n. After that I am going to create a vector of long. In this problem we can also work with integers, but I prefer working with long. So vector of long and I will call that as numbers. Then I have to iterate and n times and get the value. I'll put this value in the vector. After putting the value, now I have to iterate through the entire array to find the GCD. But before that, what I'm going to do is, since in the constraints if are given that n is always greater than or equal to 2, what I can do is I can say what GCD is. Initially, GCD is GCD of numbers of 0 and numbers of 1. In C++, you can take GCD by using underscore GCD. And now I can iterate through all the other elements and update the value of GCD. So G will be equal to GCD of G comma numbers of I. Now finally, G is our GCD of the entire array. Now what we can do is we can iterate through the entire array again. And since we have to print the entire array, what we can do is we can do a cout numbers of I by this GCD. Since the array should be space separated, I am leaving a space here. And after every test case, I have to leave a new line tag. So let us try to run this solution. While the solution gets built, let us summarize our solution. We have taken the input and stored the input in the numbers array. After that, we are trying to find the GCD of entire array. For that, we are first taking GCD of numbers of 0 and numbers of 1. After that, we move from 2 to the last element and update our GCD by taking the GCD of entire array. After that, we iterate through the entire array and then divide each element by the GCD value. And then finally, we are printing the reduced number over here, and all those numbers are space separated. After which we leave a new line character. So let us take the test case here. So this is the reduced answer, and we can see that this is very similar to the sample output. So let us take the code and try to submit it. Try to submit our code. So yes, our solution has got accepted. As you can see, in the previous solution, I have used the inbuilt GCD function. But now let us write our custom GCD function. It takes two parameters A and B. As I said, if B is equal to 0, I can just return A. Otherwise, I can return B, comma, A mod B. Sorry, I can return GCD of B, comma, A mod B. Yes. This solution looks correct. Let us try to run it. So we'll go through the GCD function once. As I said, the base case for our GCD would be if B is equal to 0, we are going to return A. But otherwise, as you can see, this is what Euclid's GCD algorithm states, that GCD of A comma B is equal to GCD of B comma A mod B. We can see that we have got the same output. We'll try to submit the code. And the code has got accepted. Like the video if you understood the problem and its solution. In case of any doubt, feel free to drop a comment below. Do try to submit your own solution on CodeChef after understanding the tutorial. If you are interested in competitive programming or you want to master data structures and algorithms, CodeChef is the one place destination for you. We post many competitive programming concepts and problem solving questions on our channel every week. To stay notified of the upcoming uploads, subscribe to our channel and hit the bell icon. Thank you.